Okay, for example 4, we are looking at writing rectangular equations in polar form. So in this case, we want to be making as many substitutions as possible. At the example at the top of your paper, right above the boxes, we were given the example x squared plus y squared equals 9. So going back to some of the substitutions from the previous video, I know in this case I can make a substitution for x squared plus y squared, which is r squared. So I have r squared equals 9. If I'm looking to get r by itself, I know I can take the square root of both sides, so I should get r equals plus or minus 3. So in this case, this r equals plus or minus 3 would be the polar form of the given equation. Looking at part A, continuing on, I'm given the equation y equals 6. So once again, I'm given y. I want to make a substitution back into polar form. So I know that y is equivalent to r times sine of theta. So r times sine of theta equals 6. And since it's my goal to get r by itself, I can divide each side by sine of theta. On the left-hand side, my sines cancel out. I should be left with r equals 6 over sine of theta, which I know I can rewrite as r equals 6 times cosecant of theta. And that is going to be my final answer for part A. For part B, I want to go ahead. I'm given x squared plus the quantity of y plus 1 squared equals 1. So I'm going to go ahead and FOIL. So I have x squared plus, I have to multiply out y plus 1 times y plus 1 equals 1. And I have to start simplifying. So we should get x squared plus y squared plus 2y plus 1 equals 1. Both of those ones cancel each other out if I were to subtract them from both sides. So I'm actually just going to rearrange this, or erase them I should say, cancel them out. So I'm going to set x squared plus y squared plus 2y equals 0. From this point, I want to go ahead and start making my substitution. So I know that r, or x, is going to equal r times cosine of theta squared, plus y is equal to r times sine of theta squared, and I'm going to add 2 times r times sine of theta. In this case, because I'm not adding or subtracting in parentheses, I can go ahead and distribute that power of 2. So I'm going to have r squared times cosine squared of theta plus r squared plus, or times, sine squared of theta plus 2 times r sine of theta equals 0. Okay, in this case, since there's an r squared in common between both of these terms, I'm going to go ahead and pull that out in front. So I have r squared times cosine squared of theta plus sine squared of theta. In this case, I have powers of 2. I'm dealing with exponents. In this last term, I don't have any exponents. So I'm going to go ahead and subtract that to the other side of the equation. So I should have that r squared times this sum is equal to negative 2 times r sine of theta. I know that cosine squared of theta plus sine squared of theta is equal to 1. So r squared equals negative 2 r sine of theta. Divide by r on both sides. And we should get that r equals negative 2 sine of theta, which of course is our final answer because I wind up with an r and a theta. Okay, so this is a much lengthier process. Please make sure that you are taking your time by distributing, simplifying, by making as many substitutions as possible. At this point, please go ahead, pause the video, and try examples A and B found below. Okay, for part A, it's very similar to what we did above. We want to make sure that we are making the correct substitution for x. I know that x is equal to r times cosine of theta. I can divide both sides by cosine of theta, and we should wind up with a final answer of r equals 4 times secant of theta. For part B, we do have to make sure that we are foiling. So x minus 3 times x minus 3. I can get rid of that power of 2 since I already foiled. Our 9s cancel out from both sides, so I can go ahead and get rid of the constants. Make sure that you are going through and substituting in correctly. So I have r times cosine of theta for x, r times sine of theta for y. I want to get anything with a power of 2, anything with an exponent on one side of the parentheses, anything without an exponent on the other side. We can factor out r squared. I can make a Pythagorean substitution for the, substitution for the Pythagorean identity. So I have r squared equals 6 times r cosine of theta. Divide by r on both sides, and we should wind up with the final answer of r equals 6 times the cosine of theta. Please make sure that you watch this carefully. Go back, kind of rewatch it if you need to, and please ask questions if you have them.